Now the last one, the last conclusion will be such that a triangle DBA is also similar to triangle DAC. Now from that we can do this. We say, let's look at side DB. Because if these two triangles that I've mentioned are similar, they are similar to each other because both of them are similar to the bigger triangle. Remember ABC. Both of them are similar to this triangle. This is the conclusion that we have come up with. Now I'm here. I'm looking at this. Fine. We are saying if that is the case, then it means we can come up with this conclusion to say DB over what from that triangle? It must be over DA or AD. This must be equals to BA over what from that triangle? AC. But since we cannot come up with the conclusion again here, we can extrapolate and take it further to say, but we know that we can have side DA over side DC, now taking the outside, over DC, also being equals to that. Now it means, since I cannot come up with a conclusion for this, I can stick by these two relations, wherein now I'm going to have DB, side DB over DA, being equals to, because they are in proportion, being equals to DA over DC. So that now it allows me to have my cross multiplication wherein now I'm going to have DA or AD squared, which is now going to be equals to DC multiplied by BD. Now these are the conclusions that I've had, guys. Now let's quickly recap, because I've said this is just an introduction of Pythagoras theorem, and say from Pythagoras theorem we know Pythagoras theorem says the hypotenuse. If we go back to our triangle, this is the hypotenuse, BC squared. This is what Pythagoras theorem proclaims. BC squared must be equals to what? Must be equals to AB squared plus AC squared. The longest side, the square of the longest side, must be equals to the sum of the square of the other two sides, AB squared and AC squared. That is what Pythagoras theorem entails. But now, for us to be able to do that, we can say we have proved the following. We have proved that AB squared is equals to BC plus BD squared. That is what we have proved. AB squared being equals to BC multiplied by DB, and AC squared being equals to CD multiplied by CB. However, when we come to this, we realize that we want BC and we want BC. Now we can express AB in terms of BC multiplied by CD and AC in terms of CD multiplied by what? Multiplied by CD multiplied by CB. From this is our AB. What is my AB? AB is BC multiplied by DB This must be squared, remember, because AB squared plus AC. From this we have said AC is CD multiplied by CB. This must also be squared. Remember, that is what we are now looking at. Fine. Now, I want us to come here and say, it means we can have this. It means we can have the following. We can have AB squared plus AC squared being equals to what? Being equals to, remember we want BC squared. We are saying BC is what? BC is equals to AB squared plus that. Now, maybe I can relate, let me relate to this as B. Remember AB squared, my AB squared was BC multiplied by, I think I was wrong, I was not supposed to do this, sorry. BC multiplied by DB plus AC squared is CD multiplied by CB. Now from this side, I mean, I can always relate to this as BC. CB can always be BC. From this, I can take out a common factor, which is going to be BC. Therefore, it means I'm going to have, if I have my BC as a common factor, it means going to leave me with what? 1 multiplied by DB plus 1 multiplied by CD. That is the conclusion that I can draw. Fine. Now, but we must not forget that we are saying this is equals to what? This is equals to AB squared plus AC squared. Fine. Let us quickly look what is DB and CB from our triangle. What is DB? DB is this. And what is CD? CD is this. CD plus BD give us BC. So it means, in essence, these are the smallest sides which make us BC side BC. Because for you to have BC, you must add BD to DC or to CD. So it means you're having BC multiplied by BC. BC multiplied by BC is what is BC squared, which is actually a theorem of Pythagoras. So by so doing, it means we have proved Pythagoras theorem. But for you to have proved that, you should have taken it from where I took it from. Otherwise, you could have not understood the similarities and these other things and the deductions that we have come up with from this lesson. I wish you had a wonderful lesson on Euclidean geometry, and I wish you carry on with this exercise. There is one thing interesting about mathematics. For you to understand this part, you need to practice it. Please let us not do it the book work. Let us try to make sense on the information that has been provided to us since from grade 8, grade 9, because I believe we have dealt with geometry from grade 8 up to grade 11. So now here we are just applying the knowledge that we have gathered in those lower grades. I wish you have a wonderful afternoon and good luck in your mid-year examination. Surely this will be there. And I thank you.